Hey, it's Dr. J. I'm back. We had some technical difficulties in the last videos, so I had to cut it off, and then I'm just going to continue it here. So division is the next part of the last video. And this will now finally be the end of chapter 1. The keyword in this section is quotient. Yeah, so if I say find the quotient of 72 and 12, then what I really mean is 72 divided by 12. Now with something like this, you could probably just do it with mental math. You could probably say, oh, how many times does 12 go into 72? And just using mental math, you know that the answer is 6. That's what we call the result, 6. If you can't do it with mental math, then you can use long division. Now, long division, you read it backwards. So this reads 72 divided by 12. And you got to be very careful that you put it in the right order. So 72 goes on the inside. We call that the dividend. And 12 is called the divisor. Okay, and so what you would really do is just say, you know, how many times does 1 go into 7, really? Or how many times does 10 go into 70? You take a guess. 7 is too many. 5's not enough. Right, 7's too many. We often call this Goldilocks. 5 is not enough. 5 would only give you 60. And so you just keep guessing until you get it right. 6. And now you multiply. 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus 1 is 7. And then you subtract. And the remainder is 0. Okay. So that's the basic idea of finding quotients with no remainder. This would be exact quotients with no remainder. Can also be written as a fraction. (72/12) or 72 over 12. These mean the same thing. 72 divided by 12. Let's do some more complicated examples like you might see in the homework. So let's divide 1188 divided by 33. I can't do that with mental math. So the dividend is 1188. The divisor is 33. And then you're going to guess. Does 33 go into 11? No. Does 33 go into 118? And just take a guess. About 3 times. Yeah. That's just my first guess. I don't know. So then 3 times 3 is 9. 3 times 3 is 9. Okay. 118 minus 99 is 19. You're subtracting. Bring down the 8. And then take a guess. How many times does 33 go into 198? 5? 6? I don't know. Want to see what happens if you make a wrong guess? So suppose I guess 5. 5 times 3 is 15. Carry the 1. 5 times 3 is another 15. Plus 1 is 16. Subtract. Yeah. 33, remainder is 33. That means that this guess was too small, because this number is greater than or equal to the divisor. So if the remainder is greater than or equal to the divisor, then that means your guess was too small. How about 7? I'm going to guess 7. Those of you that already know the answer are probably going nuts right now. You're like, it's 6. But I'm just, let's suppose I guess 7. We sometimes call this Goldilocks. Not too hot, not too cold. You want to guess just right. So if you guess 7, look what happens. 7 times 3 is 21, carry the 2. 7 times another 3 is another 21, plus 2 is 23. If this number is larger than the previous value, the previous value was 198. 231, that means that 7 was too big. You guessed too big. All right. And so now I'm going to guess just right. If 5 is too small, five was too small, 7 was too big, so 6 is just right. And you might have already noticed that because, look, 198 happens to be double of 99. So, I mean, if 33 gives you 99, well, then 6 is going to give you, 6 times 3 is going to give you 198. So 6 times 3 is 18, carry the 1. 6 times 3 is another 18, plus 1 is 19, subtract remainder 0. So the remainder, we just usually abbreviate it rem. This, and then this is called the quotient. So the quotient is 36. The remainder is 0. Sometimes you don't get a 0 remainder. 6,484 divided by 18. Let's see what happens when that happens. So the dividend is 6,484. The divisor is 18. All right, 18 does not go into 6, but 18 does go into 64. And just take a guess. 3 times. 18 is about 20. So 20 goes into 60 about 3 times. So 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus 2 is 5. Good. Subtract, you get 10. All right. If this number was larger than 18, then I know that 3 would be too small. Bring down the 8. Okay. Now go 18 goes into 108, and just take a guess. Again, 18 is about 20. So I'd say about 5, maybe 6 times. I don't know. We'll go 5. So 5 times 8 is 40. Carry the 4. 5 times 1 is 5. Plus 4 is 9. Ah, look. When I subtract here, I get exactly 18. That means 5 was too small. So I changed my guess, and I change it to 6. By the way, I already know 6 times 18 is going to exactly be 108. 6 times 8 is 48. 6 times 1 is 6, plus 4 is 10. All right. And then now bring down the 4. So 0, 4, 0, 4 just means 4. So how many times does 18 go into 4? 0 times. 0 times 18 is 0. If you like, you can put double zeros. And when you subtract, 4 minus nothing is nothing. It's 4, sorry. 4 minus nothing is 4. So I would say the quotient is 360. The remainder is 4. Okay. example 4. So let's translate and then find the result. The quotient of 2496, 2,496, and 32. Okay, so the translation, 2496. Now, this is what we often refer to as the old school division sign, but you can look all over your keyboard for it. Look all over the keyboard. You're not going to find it on the keyboard, right? I don't know why, but it's not on the keyboard. Yeah, but you might wonder where this symbol comes from. Yeah, the top dot is called the dividend. The bottom dot is called the divisor. So the way we're going to translate it is 2496 over 32. That would be our translation. Yeah. You see how it kind of looks like a division sign? All right. The result is, well, whatever we get. I don't know if I can do this one in my head. So we'll do 2496, 32. So 32 does not go into 24. 32 does go into 249. Yeah, about 7 times. 7 times 2 is 14. Carry the 1. 7 times 3 is 21. Plus 1 is 22. Subtract. You're going to get 25. Bring down the 6. Get rid of your old carries. 32 goes into 256 about 8 times. Right? Remember, the last time it was 7. So the next time it's going to be 8 because 256 is more than 224. In fact, it's exactly 32 more. 8 times 2 is 16. Carry the 1. 8 times 3 is 24. Plus 1 is 25. Remainder is 0. So 78 is the result. If the remainder is 0, we say nothing. It's mainly just because of convenience. If every time the remainder was 0, I had to say, 78 remainder 0, 52 remainder 0, that's just going to get ridiculous. So we only say the remainder if there is a non-zero remainder. The classic example or real world example or application is apportionment. Yeah, in other words, giving each person receives the same amount. Call it apportionment. Yeah. We do have the concept of proportion or proportional that comes in a later chapter. Apportionment is just where you're saying, simple elementary school example. What am I up to? 6? 5? I'm not sure. It doesn't really matter. We're almost done anyway. If you got 732 donuts, I don't know if I spelled donuts right. And by the way, person is an ambiguous term, So if each person eats 3 donuts, how many are left over? Oh, I forgot to say how many people there are. How many people are there? And how many donuts are left over? Yeah. So the donut problem. We got 732 donuts. That's a lot of donuts, right? Maybe we're having a big party, big donut party. Each person eats 3 donuts. So that's the divisor. So my dividend is 732. My divisor is 3. How many people are there? Well, that will be the quotient. Yeah, that's how many people are there. And then the leftover is the remainder. That's why we call it the remainder. It's how many remain. So 3 goes into 7 2 times. 2 times 3 is 6. Subtract. Bring down the 3. 3 goes into 13 4 times. 4 times 3 is 12. Remainder 1. Bring down the 2. 3 goes into 12 4 times. So how many people are there? There are 244 people. But 4 times 3 is exactly 12. And then no donuts remain. Okay. So 0 donuts left over. Everybody got a donut? Yep. So for my last example, suppose a coach is trying to put together teams. And they need to form groups of 9 players each. How many groups will there be? You can think of the groups as teams. We're going to have teams of 9 out of 130 people. It's a big class, a university, university PE class or something. And they got 130 people, and they're all showing up on the football field. And we're going to form groups of 9. How many players? How many teams? How many are left over? So again, the dividend is 130. Divisor is 9. 9 goes into 13 one time. 1 times 9 is 9. Subtract. Get 4. Bring down the 0. 9 goes into 40 4 times. 4 times 9 is 36. Remainder 4. So that means there will be 14 teams or groups, depending on what you're calling them. Another name for that's an association. We'll talk about that later. We'll talk about the association property or the associative property. And 4 would be left over. In other words, there will be 4 people that don't get on a team. Yeah. We'll call them floaters or something, They can fill empty spots on other teams if somebody, sprains their ankle or something, They're on the bench. All right. I know I called this the last example, but the actual last example, we're going to start doing algebra next week. And sometimes I think that I'm done, and I look at my notes and I realize I'm not done. This is what we call the distance equals rate times time. Okay. We often refer to this as the DIRT formula. Yeah, it looks like the word dirt, kind of. I don't know, D-I-R-T. All right. And we often use a dot for multiplication. In fact, all of next week, I will, be into the algebra section in chapter 2, and we will start using the dot for multiplication. All right, this formula, it's actually cool if you rewrite it like this. RT equals D. In other words, just rewrite it so the RT is on the left side and the D is on the right side. Okay. And then I like to solve for T by dividing both sides by R. Yeah. So I've got RT divided by R, and I've got D divided by R, and then R divided by R. This is a little intro to algebra of next week. And I get the time is equal to D divided by R. In other words, time is distance over rate. Rate is just a fancy way of saying speed. How fast are we going? So the actual last example, suppose you're on a trip, 816 miles. And you drive 51 miles each day. So this is a really slow trip. I don't know, maybe you're riding a bike or maybe you're just on the highway, the Highway 1 or something. You're taking a real slow trip. How many days will it take? So how many days? That's the T for time. The miles, that's your D for distance. So 816. And 51 miles per day, that's your rate. So 51 goes on the bottom. So I have 816 is my dividend. 51 is my divisor. And this will tell me the number of days. Time can be measured in days. 51 goes into 81 one time. 1 times 51. Subtract, you get 30. Whew. That was a close one. Bring down the 6. 51 goes into 306. I don't know, about 6 times. 6 times 1 is 6. 6 times 5 is 30. And there's no time left over. So the time would be 16 days. That's a long trip. That's because we're only driving 51 miles a day. Okay, I think that does, in fact, conclude it. I'm not going to, make up another example at the end. Until next time, this is Dr. Jordan saying I will see you on the internet. I'm going to hit stop.